So the pricing build-up, when we are putting a price together for metal deck, it's a build-up that we roll into the square metre rate the majority of the time, especially for the larger projects over 300 square metres. We tend to put the delivery into the square metre rate, and the installation, if you require installation, and the layout drawings. All the fixings that are included in that price all are considered within that square metre rate. So obviously if you have a day rate, for example, our day rates are between £800 to £950 per day per gang, we will be rolling that into the square metre rate of, say we'd buy the material at £20 per square metre, then you'd have 200 square metres of decking, you'd divide that 900 average pounds per day back into 200 square metres, and that will give you a rate per square metre which will be a lot higher than if you were having a 1,000 square metres, would take longer than a day to fit, but it would dilute that day rate down into a smaller square metre rate because of the volume. Okay, so there are all kinds of dynamics that we consider when we're building a price for metal deck installation. The complexity of the floor, the size of the floors. If you've got 12 floors at 100 square metres each, our gang will be erecting nets, jumping up, putting floor deck in, and then they'll be going back down again to de-rig the nets. Then they'll have to climb back up 2 floors to then erect nets, put the decking in, de-rig nets, down again, back up, doing it all again, and that is a lot more sequentially intensive than it would be if it was a 500 square metre floor space. They would spend the morning putting safety nets up, and then they would be able to get cracking the rest of the day in putting and starting flipping deck out onto a larger space. They'd spend the next day finishing off the decking, filling it in, the floor space, and then the day after that they'd be screwing all the laps and then nailing the deck down properly around all of the structure supports. So that is a much faster way to install than doing a lot of smaller areas on multiple levels or areas. So we have to consider the time constraints in that as well. Also, some city centre projects, we've got to consider noise restrictions. So you might only be able to work for 4 hours of the day making noise. Now, installing decking is a very noisy process. The guns we use make a popping sound, a very loud popping sound, around 90 decibels per pop. And the steel saws that we use when we're cutting deck around obstructions or we're ripping deck down, it is intermediate noise. It's not a constant droning of the disc cutter grinding through steel, but it is a very loud noise and can be up to 120 decibels when we're running a steel saw. So it's a galvanised steel profile that you see here, and it's very thin, but it does make a lot of noise when you're cutting through it. We find that's the fastest way to cut through decking and the most economical way. And that is the majority of our work, is popping nails into the sheets, and it's the cutting the deck that is a noisy process. Safety nets can be erected quietly during those times, but yes, so those are the kinds of dynamics that we have to consider when we're pricing our works. Let alone the delivery and the offload process. If you require us to do the offload process, we need to get a gang in there to rig and de-rig the packs and put them up onto the structure support for you, which needs to be considered in the price as well. Obviously, distance and the vehicle types that you need to take delivery. If you are having it on a shared load, it's cheaper. If you need it as a dedicated run, then it's more expensive as a focal transport cost for you, and a time delivery is also obviously an expense that we have to consider in the price build-up. All the auxiliary items that are required, like the edge trims, end caps, any special fixings that are required, the studs if required. It's a different gang, a different rig. 10 site for carrying out the stud welding process. So when we're building up a price, we're using the plans that you submit to us, the structural engineer drawings generally. We do consider the architect's slab edge detail, if available at tender stage. We take that information and we will consider the girth of the edge trim where there might be a cantilever and you need a 200 bottom leg, for example. That would add to the upstand that would correspond with the slab depth of say a 130, so you'd have a 350 girth altogether, because we have to consider the 20mm return on top of the upstand, which do have an example here of the edge trim. It's an L-shaped profile there, and that is the 20mm return that we put a restraint strap and tie it back to the top stiffener of the profile to make sure that this doesn't flex when the concrete pushes up against it. And then we fix these bottom flanges to the structure support, which usually shares the bearing of the structure support with decking. So if you've got a 203, we'd have the deck sitting on 50mm of the beam one side on the inside of the structure support, and then the edge trim on the outside, and we would just run that. If it's T-edge beam, we'd just have a 50mm bottom leg. But if you needed a cantilever off the edge of the beam, then we'd extend this so it did pop off the edge of the beam to give you that cantilever dimension. And that's why we ask for the architect's slab edge detail, so we can then notate that on our drawings to show the distance from the centre line of the beam to the outside edge of the slab, and then we determine the size of the edge trim we're going to use for that slab edge to then we price the girth that you need to achieve that. And that goes into they come in 3 metre lengths, so we do it generically 3 metre lengths, and then the guys cut them down to suit the overall linear meterage when they're on site fitting it. All profiles have their benefits and their cost associated to their benefits. So the shallower profiles won't span as far as the deeper profiles. The re-entrant profile is a very square sheet. If I show you, again, this is a re-entrant profile. Now, if you were to iron this out flat, it would be a lot wider in width. This is a 600 cover width sheet. This would be, when you flatten it out, around about 1100 to 1200mm in width. That means that the overall weight and size of that steel is a lot more than it would be for a trapezoidal profile, which is also 600 wide, but it's a lot less detail. As you can see, there's only 2 arches and stiffeners and embossments within that sheet. That would be a cheaper profile, because if you were to iron this out, you're looking at 800 to 900 width if this was a flat sheet of corner, which is how it starts off, as a flat sheet of corner. And then it's put through a roll former that forms it into the shape it is. So it enables it to be stiff enough to take the tensile strength that is required for pouring concrete onto it ultimately. And it becomes a mechanical key within the slab. So those trapezoidal, we call it, profiles are cheaper than the re-entrant profiles. The re-entrant profiles are very good for fire and acoustic values, because you get more concrete in the slab as a result of there being more concrete density within that profile, whereas the trapezoidal that you just saw with the arches, that takes out a lot more concrete than the re-entrant, as you could see from the shape of it. So the 80 deck spans further than the 60 deck, and the 50 deep decks will span the least. So they all have their benefits. Those 3 profiles are the most regular ones that are used out in the market. And then you've got the longer span 100 deep profile and a 225 type profile, or 220, that will do the longer spans, but they're a lot longer lead times and they're a lot more expensive. But again, have the benefits if you're trying to save on structure supports and make a lighter slab and save money in foundations, then they can also be a very good choice. But do consider the lead times of those profiles, and the installation is a lot more expensive because they're much bigger to handle. They take scallops on the ends of the profiles for plus 100mm that manufacture the different kinds of profiles. Those 3, the trapezoidal, the entrant, the 50, 60 and the 80 are the most regular and readily available profiles across the UK and Europe. But the 100mm plus are manufactured only by certain manufacturers in the UK and Europe, and they can attract a much higher price tag as a result. They all come in different gauges. Gauges means the thickness of the steel, and they start off at 0.9 and work their way up to 1.2. With roof decks it ranges from 0.7 up to 1.5, and again the shallower deck profiles span shorter distances than the deeper profiles. So there is a lot to consider in the price of these things, and the ranges can depend on that profile and the gauge. So when we're building up our costs, there is a lot to consider, and if you need help with budget, then just reach out and talk to me, and I'll ask you what you want to achieve, and then I'll give you the best profile that I think would suit your circumstances, and then you can take it from there. I can always help with calculations as well to show you the weight of the slab and profile together, along with the mesh and concrete on top. Same with the roof profiles. All of the metrics are considered within the design of a roof. We can produce calculations from manufacturer to suit the criteria that you need to suit, which is usually span and movings and acoustics. Coatings on the profile will help with aggressive environments and resistances, aesthetics. All of these things come into account when we're doing the pricing for projects.